my name is Daniel Osielczak. I can read it. That's one thing. I'm a system engineer at AMS-IX. I joined probably, what was it, a year and a half ago, something like that. Two announcements before I go to the presentation. One is I'm coming on the other side of a flu, so if my voice starts to break at some point, it's not because I'm overwhelmed by emotions about the presentation. It's just, yeah, I've been on medication trying to fight it off. The second is this isn't going to be about the standard stuff people talk about here, so the words BGP, root server, or I don't know, networking won't be really used, so if you're not interested, just leave now. So, oh, no one left. My mic working? Okay, so let's start. So when I joined AMS-IX, one of the things I noticed is that a lot of security stuff was fine, but people started ignoring the red thing that shows in the browser when you open a page with expired certificate. So I started looking into that. And so just to understand the entire journey, maybe I will go through basically why is it there, right? So you open a page, there is a red thing next to the address that says danger. Actually, it's not, it wasn't always there. So that means that the SSL negotiation process failed. And I won't go into the details how it works. Very quickly, it's called a handshake. The browser talks to the server, tells it, I want to make a connection that is secure. The server sends the keys to have the rest of the communication encrypted. Then the client checks if that server is actually who it is with a set of known what's called certificate authorities. So there is a third party basically here that tells you, yes, this is who they claim they are. And then they exchange the rest of the handshake, and then all the traffic is encrypted. Happy days, that's when you get the green mark and everything. The whole story behind it really, because I guess there are people here in this room that actually remember the time when that wasn't a thing, really. So in the early 2000s, for example, very few pages actually had SSL. And even those that had usually turned it off because not all the browsers supported it, and there were many different things happening. The entire story of SSL is over 30 years, if you believe it or not. And funnily enough, SSL protocol starts with version 2.0. Version 1.0 was developed in, I think, from 90 to 93, but never released because it turned out to be unsafe. Weird for a protocol that was supposed to bring safety, but I guess there was some miscommunication there. And then Netscape introduced the actual first production-ready SSL in 1995, so as I said, 30 years. But again, for years it was not really that popular. Things broken and so on. The big change really happened around 2007. Yeah, I would say 7 and 8. First thing was the EFF obviously started the HTTPS everywhere program. I think that was 7 or 8. And then 2007, it says here, Google said that they will only support sites with SSL for any customer data exchange. And that really changed things, because if you did customer data exchange and you didn't use any encryption, Google will downrank you or do any horrible things that Google does if they don't like you. So that pushed a lot of companies into that, and also that brought people that brought the knowledge to people that yeah, that there's something there that you need to have encryption if you want to send data here, especially on the internet. The rest, Let's Encrypt was a huge thing again, because 2015, it's ACME, Let's Encrypt, I think started 2015 or 16. But the big thing here is that certificates were now available to everyone. Before that, you had to pay for a certificate. It used to be quite inexpensive, then it got a bit more expensive, then it got a bit very inexpensive again when they introduced a lot of new CAs. And nowadays, I think it's getting a lot more expensive again because all the big CAs tend to bundle weird services on top of SSL. So you cannot just buy certificate anymore, usually. You'll just get a bundle of certificate plus some magic security consultancy that will give you knowledge about I don't know what. But yeah, that's the current trend. But it doesn't really matter anymore, because if you really want to, you can just go to Let's Encrypt, use their ACME protocol, and get your certificate free. It is for 90 days, obviously, but all the others will go to 90 days with time anyway. I think by 2028 or something, everyone will be at 90 days. Okay, so that was the situation at AMS-IX, basically. So the services that we offered to customers, they were almost all Intel encryption. That was fine, but internally, a lot of them were expired certificates that didn't match the actual host and so on. And people started just ignoring the red thing, or even modifying their browsers. So because from, I think, last year, most of the biggest browsers don't really allow you to ignore it anymore. I think except for Safari for whatever reason. So yeah, people just moved to Safari instead of fixing the certificates. That's simpler. So the first thing started looking at is getting the project actually defined. So what do we have? What do we actually need to be under SSL? A lot of HTTP, some FTP, some SMTP. How many? At this point, I think we're about 500 to 600 endpoints. Who uses them? That's another thing, because sometimes the assumption was that it will be HTTP without the S, and then if you want to change it, then you have to change the API endpoints in other applications and so on. What is the end goal? Obviously, everything is green. We can disable the modifications in the browser. Why so many questions? I don't know. I guess you need all that data to actually start finding a solution. This is basically like a table where we got a lot of different solutions for managing SSL certificates. We compared them based on a set of key metrics and that fit our requirements. And in the end, we find a solution that we wanted. So weirdly enough, there are very few solutions on the market for small and medium companies. There is a lot for big companies, big expensive products, and there are quite a few of open source ones, but they're usually very limited, so they only give you like a third of our actual requirements. So in the end, we found something that is called Key Manager Plus. There will be screenshots here, so you can have a look there. But now the important part, automation. Server deployed as code, obviously. Client as code. There was no client for Linux. They only have client for Windows, so I had to write our own one. It is on GitHub, so if someone wants to use it, you can just use it. We moved with the the pull model instead of push. So you update the certificate, and then the servers pull them in the next 24 hours usually. It's not possible always. I will bring some examples later on, but most of the time. And the monitoring for endpoints, obviously. If you update it, you want to know that it's updated, and you want to know where things expire or get mingled. This is a lot of different shapes. Oh, it is the process. Like if you want to better look at the process, it is very simple. It's basically what I said. So you have the endpoint. You need TLS. encryption? No, for some reason. Okay, then that's it. Yes, you go to the key manager, you scan it, you update the certificate. If it's not updated yet, happy days. If it's a non-standard, so for example, you have a weird API, OpenManage, for example, doesn't support any other certificates than generated by OpenManage. Who knew? There is another thing when the certificate expires. Again, there is automated renewal, there is DNS integration, and so on. If it didn't work for whatever reason, you can get that automated as well. There is a ton of documentation. Again, that part is really only important to people who actually work on it on a daily basis. It's more important to understand. That is how the key manager looks. As you can see, a lot of some simple dashboards. They have a ton of integration, really. That was one of the things that we really wanted. So they are integrated with all the big certificate providers, also obviously ACME. They have a Kubernetes integration, Azure, Windows, etc. So a lot of things are already working. That's the Let's Encrypt, where you just request a certificate. The DNS integration sets the DNS record. You get the certificate back. Happy days. So I'm not going to get into that. So how it works right now is you get the, if you get the certificate close to expiry, you renew it there in Key Manager, and then the clients come in and download it. And that's really all the work you need to do on certificates anymore. Well, most of the time, really. Again, there are some things where the automation is really hard because, as I will mention here, the API documentation, for example, is horrible for a lot of things. So especially Dell, they really don't know how to write documentation for API. Basically, it's all mingled. The endpoints are mingled with the responses. I don't know who did that. I don't know if anyone uses it. It's really hard to figure out. Those are the few things that actually came out during the creating the integration. So one is edge cases testing. Again, a lot of endpoints, a lot of different scenarios. So at first we didn't have that, which caused some issues. The second, feedback is crucial. You have a lot of stakeholders, so getting feedback from everyone is really crucial, because then you miss a lot of things that are not absolutely obvious. Like, for example, at first I only did browser testing, and as it turns out, the RFC 5280 that defines the SSL encryption, it has a very vague statement about it. So the certificate that needs to be provided by the server must be leading to an acceptable certificate authority, which is seen differently by browser providers or by library providers. So some consider the intermediate certificate as the acceptable certificate authority, some don't. So again, test your stuff before you release it. And because I'm, oh shit, I'm really out of time. Okay, the going forward, the SNI, that is a bit of a question, because we mostly based our searches on the certificate's common name. So SNI is a bit interesting to automate intermediate search. Again, some of them don't really come automatically, so you need to figure that out. And high availability, although that is not really that important. The certificates, they are 90 days, so you still have time. Even if your server is not available for 2 hours, it's usually fine. So that's why it's still on plan. And I think that is it. Yes. How much time do we have? How much time do we have?
All right. Let's see. No, we're really over time. So, but you'll be here the rest of the day, I think.
Yes, I'll be here the rest of the day, and I will be beating Leroy's offer. I only take half a beer.
So you heard it. If anybody has questions for Daniel, please offer him a beer later on during drinks, and he'll be happy to answer. Daniel, thank you very much.
Thank you.